Let us look at some commercial linear regulators. The MuA78 series regulator is a very popular and commonly available linear regulator. It is a 3-pin, you see here, 3-pin, 3-terminal linear regulator. You have the input, the output and the common pin. Very popular, and it comes on various fixed outputs. 78XX or 00 series. If you get 7805, it is a 5-volt regulator. If it is 7808, it's a 8-volt regulator. 7810, 7812, 12 volt, 7815, 15-volt regulator, so on. Very popular. Output currents up to 1.5 amps. And it's available in TO220 package. See here different 78XX series. This is a 5-volt regulator. This is a 8-volt regulator. The 12-volt regulator. This is a 15-volt regulator. 24-volt regulator. So on. So these are constant voltage regulators. Just 3 terminals. You put these 3 terminals, no other extra components, and you're in business. In the data sheet of the 78XX series, you will see some of the important parameters. The output voltage, minimum 4.8 to 5.2. Now the input voltage regulation. Okay. So for a variation from 7 to 25 volts, 3 to 100, you should map it into the regulation coefficient that we just now discussed. Ripple rejection, output voltage regulation, that is with respect to the load. There is a temperature coefficient of output voltage with respect to variation in temperature. These are the regulation coefficients that would matter, and you will have to use these in effectively designing your regulators. Another versatile precision regulator available in the market is the 7803. Another versatile precision regulator available in the market is the MuA723. It comes in a DIP package and a few other packages as well. It is a 14-pin IC. Of course, many of them are not connected, but you will see that the internal block diagram of this regulator is very similar to the discrete regulator, series regulator that we discussed, and you will see that many of the features that we have discussed is already implemented in the IC form in this regulator, and you can make the best use of it. Here are some datasheet values. Input voltage 9.5 to 40 volts max. So we'll have to stay within that for an output voltage. See, 723 is a variable precision regulator. You can set for different output voltage from 2 to 37 volts. Input output differential voltage. This is an important parameter. Should not exceed input output differential voltage of 38 volts, and you should keep a minimum of 3 volts. And you have a 150 milliamp output current possibility. Here too, look at the regulation coefficients. Input regulation, typically 1 and maximum of 5 millivolt per volt. Ripple rejection, output regulation, and you have the temperature coefficient output voltage. Now these are the important parameters that you should consider in doing your design. Look at this. This is a typical circuit given in the data sheet for the 723 regulator. So this is where the unregulated VI is given, and internally reference is generated. You don't need to put an external Zener. So internal reference can be used and given to the plus terminals of the op-amp, internal op-amp. Even the op-amp is internal, and to the minus terminal you will give the output that is fed back. And there is a facility to add RSC, short circuit protection, or the current limit through this across these terminals. Then you have the current sense. So this is a typical case what we discussed in the discrete version. LM723 3 also provides you with facility to provide an output transistor on the output side to provide a current boost. Let us say this internal transistor is capable of taking 150 milliamps and you want 1 amp at the output load current. You can put a current boost and then increase the current capability. Observe again from the data sheet of MUA 723, they have implemented the fold back current limiting. The transistors are internal, the resistance you have to put external, and you see the fold back current limiting operation. LM317 is another 3-terminal adjustable regulator. I will discuss this a bit more in detail later. Another version of LM317 called the LM350 is also a 3-terminal regulator. LM317 has 1.5 amp output current rating, whereas LM350 has 3 amp rating. So they are powerful regulators for quite a reasonable amount of power. Here too you have just 3 terminals, the input, output and the adjust. There is a fixed voltage between the output and the adjust, and that is used as the reference voltage, and that is what is used for achieving adjustable output voltage regulator. In the electrical characteristics of the data sheet, you see for the LM317 line regulation aspect, it is given here in terms of percent per volt. You have the load regulation given here, thermal regulation. So all these aspects are given and you will have to map it to the regulation equation that we discussed. Another important aspect that you need to note that in most of the data sheets you will find R theta JA, junction to ambient thermal resistance. So from the core of the regulator should not cross 150 degrees centigrade, and to be on the safe side we set it at 120 degrees centigrade and pass on the heat to the ambient. How do you pass on the heat to the ambient? You can use the thermal resistances given here in degrees centigrade per watt. If they do not give reasonable thermal flow, you may have to put extra additional heat sinks. Now that is very, very important if any of your regulators or semiconductor devices has to function properly.